move on to our next question. Here. So the question asks to turn 270 degrees to radians. So 270 degrees to radian is our question. Okay. So two formulas that we might be using when converting from degrees to radian or radian to degrees is this one. So if you want to turn from degrees to radian, you take the degree. I'm just going to use the blue color so it's easier. Take the degree and you times it by pi over 180. Degrees. And then there you go, you get your rad or radian. If you want to turn from radian to degrees, you're going to have to do the opposite. So you're going to have to take the radian and you're going to have to times it by 180 degrees and divide that by pi. And there you get your degrees. So in this question, in our example, we're going to be using the first formula right here, this one, and we're going to take 270 degrees and we're going to times it by pi over 180. Degrees, which equals to 270 pi over 180. And the degrees sign on both the ends cancel out. So again, we're just left with 270 pi over 180. Now we can further simplify that by dividing. So the easiest to divide by is by 10. So we're just gonna get rid of the zeros and we're left with 27 over 18 pi, which can then be turned into 27 over 18 pi by 1/8. This can be further divided by, let's say, 3, and if we divide each of the, because you have to divide the numerator with the same number you divide the denominator. Whatever you do to the numerator, you have to do it to the denominator. And so if we divide that 27 by 3, we're left with 9 over 18 divided by 3 is 6. And don't forget the pi. We can further divide this, because it has to be in the simplest form, by 3 again. And we are left with 3 over 2 pi. So you can put that in your calculator in radian and figure the value out, but figure like the approximate value, but this is the exact value for that question. Okay, so So our next question is also pretty simple. We're just gonna need to convert 1.85, which is decimal, to a fraction. So first step, we're just gonna write down our decimal, and for it to be a fraction, we need a numerator and a denominator, and we need to get rid of the decimal point. So So one way of getting rid of the decimal point is to times it by 10, because if we times it by 10, this decimal place is going to move 1 over to the right and it's going to disappear. So if we times it by 10, we are left with 15. However, don't forget that the decimal also has like a 1 at the bottom of it. So whatever we do to the top part, numerator, we have to do to the denominator. So if we're timesing the top part by 10, we have to times the bottom part by 10. Otherwise, the function won't be the same, or the value won't be the same. So if we times it by 10, that becomes 15, and 1 times 10 becomes 10. So now we have a fraction. Another way to think of it is that if we didn't times the bottom by 10, we basically are saying that 15 is equals to 1.5, which is not the case. So in this example over here, we are left with 15 over 10. We can further simplify this, and we will, because fractions are better when they're simplified. We can divide both by 5. Here. And we are left with 15 divided by 5 is 3, and 10 divided by 5 is 2. One way to verify this and see if it's correct is you can just plug in 3 over 2 in your calculator, and you're going to end up with the initial value that we had, which was 1.5 over here. So yeah, I'm just going to box this. Also, this is this is an improper fraction because the numerator is greater than the denominator. We can also write it as a proper fraction. So for us to do that, we just take the denominator and however many times it can fit in. So 2 can only go in 3 ones, so we have 1. And then our remainder, so basically 3 minus 2 is 1. So our numerator is 1, and over 2, the denominator remains the same. In order to verify this, what we can do is multiply the denominator by the whole number. So 2 times 1 is 2, and then we just have to add in the numerator. So basically, we're just timesing this and adding this to it. Yeah. Okay. And that is also the correct answer. Is correct, and we're going to move on to the next question. Square root of infinity. So this one's a little bit of a harder question, maybe like college level. So we're going to do that. So initially, question 4 is the fact that if you choose a number and you multiply it by itself, you end up with the square of the number, or you have squared the number. So in this case, infinity is not a number, it's just a way of expressing something. So infinity times infinity equals infinity. Basically, it says infinity times infinity, or infinity squared is infinity. So if you want to square root infinity, you're kind of gonna get the result of infinity. But we have a mathematical way of proving that, so we're gonna use limits to do that. So we're gonna say that the limit of x as it approaches infinity is equals to the square root of x, because that's our function, square root, is equals to infinity. Okay. So then we're going to say that the limit of x as it approaches a of a function to the power of b, because that initially is 1 over 2, is equals to the limit of x as it approaches a of f of x to the power of b, with the exceptions of intermediates. If you guys don't know what those are, I'm just going to write them down for you. There are 7 intermediates, I believe. So first intermediate, we have is, I'm just gonna write that down in blue. So basically all the like final answers are in blue, and all the questions are in red, and the important like stuff is highlighted is in red. So once again, black is just for solving the question, blue is for any of the equations, and red is for final answers. So any of the intermediates are positive or negative infinity over positive and negative infinity. Then we have if 0 is being divided by 0. Then we have 0 is to the power of 0. There are 4 more, I think. Yeah. So we have if 1 means the power of positive or negative infinity. Then if we have positive or negative infinity being dotted with 0. Oh. That is a dot. 0. Then we have if infinity to the power of 0. We have infinity minus infinity. Okay. So 1, 2, 3, 4, 5, 6, 7. 7 intermediates right over here. So next, we're gonna, from the previous, we've established that from the previous, over here, let's scroll down, that we're gonna square root this whole thing, that's equal, square root that, and then the limit of x as it approaches a, x as it approaches of x Next, we're going to apply the common limit. So the common limit rule. Scroll down. Which basically just states that the limit of x as it approaches infinity of x is equals to infinity. Equals to infinity. Okay. Then we can continue on saying that basically based on this equation over here. We said that the square root of a limit of x as it approaches a of x, that's our function, and over here, the limit of x as it approaches infinity of x is equals to infinity. So basically, we're going to replace this over here, and that equals to the square root of infinity, which, if we apply the if we apply the infinity property, we apply the infinity property, which basically states that infinity to raise to a constant is equals to infinity, and over here we have infinity as raised to the power of 1 over 2, because the square root is basically raised to the power of 1 over 2, and that is how we get infinity. So to sum it up, the square root of infinity is equals to infinity. Just put a red. Edit. And okay, our next question states, evaluate the following expression, and we have log, what's the question? We have log 3 of log 28. Okay, so our first step of the thing is to isolate each part of the question. So we're going to first approach this part, which is log 2 to 8, log with the base of 2 to 8. And we're going to use the log rule, which that was it. So we're going to use, you could put it in a calculator, but I'd rather think of it as how many times does 2, or to what power does 2 have to be multiplied to get 8? So if we do 1 to to raised to the power 1 is 2. If we use 2 raised to the power 2 is 4. If you use 3, 2 raised to the power 3 would equal 8, which means that this is equals to 3. We can put this into our normal equation now, which is log 3 to the base 3. Also, when solving a question and the bottom is not given, like if it's not stated, we automatically assume that it's a 10. Otherwise, if it's not a 10, another value will be given. So over here, we have 3. We're going to use the log rule. So the log rule basically states, I'm just going to write that down. Log rule. That if a number log is being multiplied by itself, so the power a and then a here, so if these two values are the same, so over here we have 3 and 3, then the whole thing equals to 1. So in this case, we do have that. We have log 3 is 3, and we know that these two are the same, so that is equals to 1. Just gonna box it in. It's always important in tests or anything to just box your final answer in so the teacher knows. Yeah. Okay, so in this example, we have to find a fraction that is equivalent to the fraction that is given to us. So the fraction that is given to us is 5/8. And basically what it's asking us to do is come up with a different set of numbers that have the same exact value. So a way you can do that is multiply. Okay, one rule you have to remember is whatever you do to the numerator, you have to do the denominator. So if you multiply the numerator by 2, you have to multiply the denominator by 2. And so over here, we can take another number, let's say by 3. So we multiply the top by 3, and we also have to multiply the bottom by 3. So that results in 15 over 28. Yeah, 24. Sorry, 24. So over here we have this example, so 15 over 24. Another way we can check this if it's equivalent to this is we can divide it by the same number. So we divide it by 3, it will result in 5. And if we divide it by 3, like the denominator, it will result in 8. So here we can do another example of the same question. Okay, so here we can do the same thing. The only thing that we don't have to multiply, that we can't multiply this question, is by a 0, because you can't multiply a fraction by 0. We can do another example with the same scenario, like the same question, so 5/8. We can multiply each by 5. We have to make sure that's the same value because, again, whatever you do to the numerator, you have to do it to the denominator. So times it by 5 and times this by 5 is equals to 5 times 5 is 25. And 8 times 5 is 40. So, again, we could just write down the final answer being any of the following. A way to write equivalent is okay, so here the fraction 5/8 is equivalent to, either we can put 15/24 or 25/40. It's the same thing. Oh, sorry. Um, 15/24. Again, if you put in the calculator, if you divide 5 by 8, you're going to get the same value as when you divide 15 by 24. And get 40. And that is our final answer. We could do similar problems of the same thing, so we can take a different set of numbers. So here we're given 3/5. So we're going to take 3/5. And we can pretty much multiply by any number. We can multiply by 100, by 25. But just again, reminder that whatever you do to the numerator, you have to do to the denominator. We can also divide them, but that's their thing. So we'll multiply them by, let's say, 3 this time. 3 and times bottom by 3. That will equal to 3 times 3 is 9. And 5 times 3 is 15. So, basically, it's saying that 3/5 is the same as 9/15. We could do another example, the same thing. Let me just highlight this again. Like box it in, basically. Another example we're given is 4/7. So the fraction 4/7 is equivalent to, we can times this by, let's say, 5 this time. So the top by 5. Okay. And the bottom by 5. And we're left with 4 times 5 is 20, and 7 times 5 is 35. So again, if you put this in your calculator, So 20 divided by 35, you're going to get the same value as when you divide 4 by 7. So just final answer. Okay. So for this question, it is a simple algebraic kind of question. So we're given, I believe this is question 7. So we're given x plus 7y is equals to 10. We're going to name this our first equation. So just going to write 1 beside it. And our second one is 3x minus 2y is equals to 7. And this is going to be our second equation. I'll highlight that. And we can continue on from there. I like to use substitution, so it's basically isolating for one variable in one of the equations and basically substituting that into the second equation to solve for the values. So we're going to be doing just that. We're going to take our first equation, and I think the easiest variable to isolate for is x, because it's already by itself. We don't have to divide or anything. So we're just going to write the equation down again. X plus 7y is equals to 10. And I'm just going to move. So I'm going to move the 7y over to the other side so that x is alone. I can do this by minusing 7y on each side. So 7y on this side and minus 7y on that side. This and that will cancel out, and we are left with the equation x is equals to 10 minus 7y. We can call this our new equation, so the third equation. And what I'm just going to do is I'm going to substitute our third equation into the second equation. And there we go. And I'm just going to move this down. So our second equation was 3x. So for every x you're going to replace, you're not going to write x, you're going to write down this part of x, because x equals this. So in brackets I'm going to put 10 minus 7y bracket minus 2y is equals to 7. So then we can multiply the 3 in. So 30 minus 7 3s are 21. 21y minus 2y is equals to 7. Our basic goal is just to get one variable that we can isolate for at the very end. So we're just going to take the 30 onto the other side, and we're going to add the two y's, so negative 23y is equals to, when we take the 30 to the other side, or basically subtract 30 from each side of the equation, this is going to cancel out, and it's going to be 7 minus 30, which equals to negative 23. We can divide each side because we have to isolate for y by negative 23. 3, and we get y is equals to 1. I could have done this a long time ago. And then now we know that y is equals to 1, so we can go to any of our 3 previous equations and basically just put y in it. I think the easiest one to do so would be this equation right here. So our third equation, which is x is equals to 10 minus 7y. So I'm just going to write that equation out. X is equals to 10 minus 7y. Now we're just going to substitute our y into our equation, which means 10 is equals to, x is equals to 10 minus 7. We're going to put 1 in for y, and that equals 10 minus 7, which is 3. So our x is equals to 3. Okay. A way to kind of verify this is if we take any of our values, so take y for example, and we plug it into another equation. So over here, let's use equation 2 for example. 3x, and we also take our y in. So our y is 3. Our x is 3 and our y is 1. So we put into the second equation. 3 times x is 3. 3 times 3 is 9 minus 2y. Y is 1. 2 times 1 is 2. So 9 minus, I'm just going to write it down in blue over here. We get 9 minus 2, which equals to 7, which is the answer over here. If it equals the answer that's already there, or the equation equals to the other side of the equation, one side of the equation equals to the other side of the equation, we will equals to 7. It will equal to 7. And so now we have our question, and those are final values. We can write them down at the bottom. Y is equals to 1. This is not necessary, but like you can write it down if you want to. X is equals to 3. Again, I'm just going to square it. So again, we just have to isolate for one of the variables. That'll be our first move, to isolate for our variables. 2 would be going to, third. and in this case our x is equals to 3 and y is equals to 1. That's correct. Okay. So once again, thank you for listening. Those are all the questions for today. If you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and notify bell below. If you'd like to submit your own questions, visit the links in the description. Remember to leave a like and comment and share this video with your friends. This has been Shenaeze from OneClass. I hope to see you soon. Bye.